From the smallest atom to the largest galaxy, the universe is awash in information. It's woven into the fabric of reality. We see it in the spiral of a seashell, the dance of planets, the complex code of life itself. But what if this information, the very essence of order in the universe, is more than just a concept? What if it has a physical weight, a measurable presence in the cosmos? This is the intriguing question that lies at the heart of the mass-energy information equivalence principle. Melvin M. Vopson, a physicist with a daring vision, stands at the forefront of this scientific revolution. His work challenges the conventional boundaries of physics, exploring the connection between information, energy, and mass. Vopson's journey began with a simple question. If information is truly fundamental, shouldn't it have a physical presence? This question led Vopson down a path of exploration, drawing inspiration from the work of pioneers like Rolf Landauer. Vopson's research looks into the very essence of information, seeking to quantify its mass and understand its role in the universe. His mass-energy information equivalence principle suggests that information itself is a form of energy and therefore possesses mass. This principle, still in its theoretical infancy, is already sending ripples through the scientific community. The idea that information has mass might seem strange at first. Vopson's principle goes beyond our everyday experience, venturing into the quantum realm where the lines between information, energy, and mass become blurred. In a physical system, like a computer chip, these choices are represented by the arrangement of electrons, the flip of a bit from 0 to 1. Vopson's principle suggests that even the most ethereal piece of information, a single bit, has a corresponding mass. This mass is incredibly small, far too tiny to be detected by even our most sensitive instruments. Just as an atom possesses mass, so too does a bit of information, albeit on a vastly different scale. To grasp the essence of Vopson's principle, we need to journey into the heart of matter, where bits of information and fundamental particles intertwine. Imagine a single atom, the building block of everything we see and touch. Now imagine that atom containing a single bit of information. Storing this information within the atom requires energy. According to Einstein's famous equation, E=mc², energy and mass are intimately connected. This means that by adding a bit of information to our atom, we've also increased its mass, albeit by an infinitesimally small amount. This relationship between information, energy, and mass is at the heart of Vopson's principle. If Vopson's principle proves correct, it could revolutionize our understanding of the universe. It would mean that information, like matter and energy, contributes to the overall structure and evolution of the cosmos. Imagine the vast amounts of information contained within every star, every planet, every living organism. According to Vopson's principle, this information would have a measurable mass, however small. It would contribute to the gravitational pull of celestial objects, influencing the cosmic dance of galaxies. If information has mass, it means that our digital age, with its ever-increasing data storage, is literally adding weight to the universe. Vopson's principle opens up a Pandora's box of intriguing questions. To truly grasp the revolutionary nature of Vopson's work, we need to look into the fascinating world of information theory and its intersection with thermodynamics. This is where Rolf Landauer, a visionary physicist, enters the stage. Landauer, in the 1960s, proposed a groundbreaking idea. Erasing information, even a single bit, comes at a cost. Not a financial cost, mind you, but a thermodynamic one. Landauer's principle states that erasing a bit of information at a given temperature always releases a tiny amount of heat into the environment. This heat, though incredibly small, is not negligible. It represents the fundamental cost of resetting a bit, of returning it from a state of knowing to a state of unknowing. Landauer's brilliance was in recognizing this fundamental link between information erasure and energy dissipation. Vopson, inspired by Landauer's work, saw a deeper connection, a hidden bridge between the realms of information and fundamental physics. He recognized that Landauer's principle, confined to the world of thermodynamics, could be extended could be integrated into understanding of Einstein's universe. Einstein's famous equation, E=mc², tells us that energy and mass are not separate entities, but two sides of the same cosmic coin. Vopson's genius was in recognizing that Landauer's principle, when viewed through the lens of Einstein's equation, suggested something extraordinary. If erasing information releases energy, and energy is equivalent to mass, then information itself must have mass. This simple realization forms the bedrock of the mass-energy information equivalence principle. By combining the insights of Landauer and Einstein, Vopson constructed a bridge between information theory and fundamental physics. This bridge could lead to a profound shift in our understanding of the universe. Vopson's principle paints a picture of the universe where information, energy and mass are engaged in an intricate dance, a cosmic ballet of creation, transformation and annihilation. Information, no longer an abstract concept, becomes a tangible entity, a participant in the grand unfolding of the cosmos. Imagine the birth of a star, a fiery crucible where hydrogen atoms fuse into helium, releasing unimaginable amounts of energy. This process, according to Vopson's principle, is not just a nuclear reaction but also an informational one. As the star ignites, it acquires information about its temperature, pressure and composition. This information, encoded in the matter of the star, contributes to its overall mass. Vopson's principle suggests that information is not merely a passenger in the universe, but an active participant. Vopson's principle, for all its elegance and grandeur, might have remained in the realm of intriguing speculation, if not for a crucial element, testability. Vopson sought to ground his ideas in the tangible world to find a way to measure the elusive mass of information. This pursuit led him to a remarkable calculation, a numerical value that could potentially unlock the secrets of information's physicality. Based on his theoretical idea, Vopson calculated that a single bit of information at room temperature possesses a mass of approximately 3.19 times 10 to the negative 38 kilograms. To put this number into perspective, imagine the smallest grain of sand you can possibly conceive. Now, divide that grain of sand into a billion pieces. The mass of a single bit of information is even smaller than that. The mass of a bit, though seemingly insignificant in its tininess, carries huge implications for our understanding of the universe. It suggests that the seemingly ethereal realm of information is not separate from the physical world, but intimately intertwined with it. Every bit of data, every line of code, every thought that flits through our minds has a corresponding mass, however small. This realization challenges our traditional view of the universe as composed solely of matter and energy. Information, according to Vopson's principle, emerges as a third fundamental constituent of reality. If information has mass, it means that the digital age, with its exponential growth in data storage and processing, is literally adding weight to the universe. It's a mind-boggling concept, one that highlights the interconnectedness of the digital and physical realms. As we look deeper into the information age, our technological prowess continues to astound. Data storage devices shrink in size while their capacity explodes, cramming ever more bits of information into ever smaller spaces. But what are the implications of this relentless data accumulation on a cosmic scale? Vopson's principle offers a startling perspective. The universe itself might be getting heavier. Every byte of data stored, every email sent, every calculation performed adds a tiny, almost immeasurable amount of mass to the universe. While the mass of a single bit is infinitesimally small, the sheer volume of information being generated on a daily basis is staggering. Over time, this accumulation of digital information, according to Vopson's principle, could have a measurable impact on the overall mass of the universe. It underscores the interconnectedness of the physical and informational realms, challenging us to reconsider the true nature of the universe we inhabit. We are taught from a young age about the three states of matter: solid, liquid and gas. Later we learn about plasma, the fiery state of matter found in stars. But what if our understanding of matter is incomplete? What if there exists another, more fundamental state, one that underpins the others? Vopson's principle suggests a tantalizing possibility. Information itself could be that fifth state of matter. Imagine information not as an abstract concept but as a fundamental entity, like the particles that make up atoms. Just as electrons and protons combine to form atoms, could bits of information, governed by their own set of laws, combine to form the building blocks of the universe as we know it? Information, by its very nature, is more elusive, more ethereal, yet according to Vopson's principle it possesses the defining characteristic of matter mass. If information is indeed a state of matter, it begs the question, what role does it play in the grand scheme of the universe? Vopson's principle suggests that information is not merely a byproduct of physical processes, but an active participant, a fundamental building block of reality itself. Imagine the early universe, a chaotic soup of energy and particles. As the universe cooled and expanded, information, according to this view, played a crucial role in shaping the cosmos. Bits of information representing fundamental properties like charge, spin, and mass could have combined and interacted, forming the first particles, the first atoms, the first stars. In this information-centric view of the universe, the laws of physics themselves could be seen as a form of information processing, a cosmic code that governs the interactions of matter and energy. The universe, in essence, becomes a giant computer, constantly processing information, evolving and creating new structures. This perspective has serious implications for our understanding of reality. It suggests that the universe is not merely a collection of physical objects, but a vast interconnected web of information constantly being processed and transformed. The idea of information shaping the universe might seem like science fiction, yet Vopson's principle, grounded in physics, supports this possibility. Could information influence matter and energy, shaping the universe? Consider the intricate structures of galaxies, the balance of forces in solar systems and the dance of molecules giving rise to life. Could information in the quantum world guide these processes? Vopson's principle suggests information influences the universe's evolution. Just as gravity shapes the cosmos, information could drive complexity, order, and life. In our digital age, the relentless pursuit of more storage and faster processing has led to an explosion of data. We generate, store and share information at an unprecedented rate. Vopson's principle suggests our data storage devices might be slightly heavier when filled with information. The difference is incredibly small, but it would be there, confirming the physical reality of information. It's a thought-provoking concept, highlighting the unexpected ways our digital lives impact the physical world. The allure of Vopson's principle lies in its potential to revolutionize our understanding of the digital realm and its far-reaching implications for the universe. It posits that all forms of information possess mass. Consider the intricate dance of life, where information is encoded in our being. Genes carry vast amounts of information shaping our traits. The universe itself is a vast repository of information. From galaxies to subatomic particles, all properties can be seen as bits of information. Vopson's principle challenges us to see information as an integral part of reality. Vopson's mass-energy information equivalence principle could unify our understanding of the cosmos. Information is a fundamental ingredient, connecting the digital world to the universe. Imagine a universe where information actively participates in the cosmic dance, the laws of physics as information processing, governing matter and energy. Complexity from galaxies to life is influenced by information. This view offers a glimpse into a more interconnected and dynamic reality. We are active participants, our actions sending ripples through the universe. The mass-energy information equivalence principle represents a bold leap in our understanding of the universe. It challenges us to see information as a fundamental constituent of reality. Experiments are being designed to test Vopson's predictions. Confirmation would herald a new era in physics. It would transform our understanding of the universe. If information has mass, it could revolutionize energy storage and computation. The future of information is bright, holding the key to the universe's deepest mysteries.